What'd she say?
Talking about me, don't I? She said, that's the experience.
Oh, I knew what you meant. Oh, it moved by itself. All right, let's get through this. Today's lesson will be longer than yesterday's lesson. Yesterday's lesson was, as you know, quite simple. And we earned that right to have that simplicity by all the hard work we had done, but we'd never done this before. So today is the 24th. And nowhere near as cool of a date as 1/23/23, but it is 1/24/23. And we are solving systems again. But today we'll be using a method called substitution. If there's any graphing that happens today, it will just happen like in the moment, where during the lesson I might decide to show you that, hey, we could do this like yesterday, just to sort of verify with you that, like, wow, this actually works. But it's a really cool method. This is the first of what we call the algebraic methods. Yesterday's was called graphing. So I think I said this in the lesson. There are 3 methods that we teach you for solving systems. There's graphing. It's like its own thing, which is great. But then we have 2 other methods that are algebraic, meaning non-graphy, all X's and Y's and moving things around. I shouldn't say obviously, I hate graphing. Like, graphing is not something I enjoy doing. I can do it, but I don't really care for it. So I much prefer these methods myself. I find the act of getting out graph paper and doing all that to be just a chore. So I think that if you're a mathy person, you'll like these methods better too. And graphing doesn't always practically work. Like, it's not always a practical thing to do if the numbers get big or if the lines don't cooperate, things like that. So I have 5 examples for you today. I'll walk you as deliberately and slowly through these as I possibly can. So here's your first one. Good morning. You guys know what form these are in? Would you remember by chance what this is called? They're obviously not slope-intercept. Huh? No, in fact, I'm not actually sure that we've ever, no, we have, but this is called standard form. I don't even really care if you know that right now, but I think every problem you see today, the equations will be in standard form or close to standard form. So they'll be kind of more messy like this. So I'm going to give you some steps, and I may not write them down formally the first time. I'm going to just kind of walk you through an example so you can kind of get the flow of this. This step, I hope I have you listening, because 20 minutes is what the scientists say I get. After 20 minutes, science shows that humans stop listening. So I hope you're still listening. This is the killer step, the first step. You look at the 4 variables. There are X, Y, X, and Y. That's 4, right? And I want you to pick the one that would be the easiest to get by itself. And I hope by this point in the year, you know what I mean by that. Which, if I said get one of the 4 variables by itself, which one would be that one? Definitely. And we want to be specific and say the top Y, right? Because there's a top Y and a bottom Y. And why is that top Y so easy to get by himself? Because it doesn't have a number with it. It has a plus sign, which is a meaningless positive 1, which means if I just get that 2x out of there, I'm done. So that's going to be step 1. And again, we'll write these steps formally down in a bit if you'd like. But step 1 is pick wisely. And that is get a variable that's easy to get by himself and do that. So we're going to take the top equation now. And over here off to the side, we're going to get y by itself. It's not because we love getting y by itself. It's because in this case, y is the path of least resistance. For the record, this method will work if you choose poorly, but you're just opening up a can of something that you don't want to open up. It gets into fractions and just, yeah. So always choose the first step wisely. So if I go off to the side now and I get that y by itself, it will say y equals what? Nice job. Any questions about that? Okay, the next thing I'm going to do, and I'm a big believer in this, what I'm about to draw, is everything after the equals sign. If it says y equals, everything on the other side, I'm going to put it in a box. And you'll see that I constantly am making reference to this box. The box for me becomes like this real physical thing that I can move around and keep referring back to throughout the problem. Now here comes where it gets its name, called substitution. By saying that y equals the red box, that means, listen carefully, that I am within my rights to now go anywhere else in the same system, and if I see a y, I can pull the y out and put the red box in its place. That's what substitution means, is to literally, it's like a substitute teacher. You take your teacher out and you substitute another teacher in. So that word is quite literally take something out, put something in. So I hope this is obvious. I don't want to go to the top equation and replace the y with the box because that's the equation that I got the box from. So what I'm going to do now is I'm going to go to the other equation that I didn't use, and where it says y, I'm going to replace that with just an empty set of parentheses for the time being. So that bottom equation is now going to say 5x plus 3 awkward void equals -12. Again, the y is not there anymore. In its place, I have put an empty awkward space. And what will I put into that space? Very good. So -2x minus 6 replaces what used to say y. And if you're seeing things through a very clear set of lenses, you now realize that that red and white equation is something we did back in August. Like we've been doing this all year. It's a simple, probably 3-4-step equation. There's absolutely no meat on that bone. So let's solve that red and white equation. What do we do first? Definitely distribution. So we have 5x. What's after that? Minus 6x minus 18 equals -12. And I'll put little blue arrows here for those of you who wonder how we did that and are too bashful to ask. 3 times that and 3 times that. That's what that distribution is, of course, all about. So there's one step. Let's do another step now. I believe we should combine some like terms, huh? What is 5x minus 6x? Yeah, just -1x minus 18 equals -12. If I were working on my own, I would have also added the 18 across in my head while I was at it. So you're welcome to do stuff like that. I didn't want to in this case, but I would. And now I am going to add the 18 to the other side, which is going to leave me with -x equals what? +6 for sure. And if -x equals +6, what does x equal? Very good. So at this point in the system solving process, you can basically say, I know half of my answer. If you remember from yesterday, our answers are ordered pairs. So I'll be consistent today. And when I write answers, I'm going to write them in yellow. So that'll be my thing, okay? So I'm going to start writing my answer, and I'm going to say x is -6. So I can put that in the spot that goes first, of course, because x, y is the order that we put our points in. So what's left for us is to say, well, great. So I know the x coordinate of where these lines would have crossed, but I don't know the y. And that red box that you see up on the TV, that's going to always be my go-to. Literally 100% of the time. I've never in 27 and a half years taught a substitution problem to Algebra 1 kids and not used the box, ever. And I won't. There's no reason. Because the box provides for me exactly what I want. The box literally says, Y equals, let me give you Y. If you just put your X into the box, I'll give you back what you want. So you just got to do a little fourth, fifth grade math here. Imagine X now being replaced or substituted with the number -6. Follow along. What is -2 times -6? +12. And what is 12 minus 6? Therefore, the answer is 6, -6, 6. That means if we were to have done this like we did yesterday, getting y by itself on both equations and graphing both lines, we would see them cross at the point left 6, up 6. But again, we're not graphing. So that is an algebraic way to solve a system. All right, let's do another one. And this time I'll try to give you some, for people that like having like steps to follow, like step 1, step 2, I'll try to make you some good steps. So let's do another example. Did that make sense? Nice. It's nice. It's enjoyable. Math people really enjoy this process. I always say that because like some people really like math and some people, they just tolerate math. But if you really like math and the act of doing math, these are kind of fun, I hate to say. They just feel kind of good. So remember, choose wisely. Who's going to be the path of least resistance here? Bottom X, exactly. Not even a debate. So in the bottom equation, I see that getting X by itself will be absolutely simple. So I'm going to say now, okay, X equals X, you're by yourself. What would X equal? Good. So let's make some steps here. Do you guys like steps? Yeah, okay, let's do step 1. Um, let's do this. Choose the variable with no number. Does that make sense if we just write it like that? Yeah. Comma, and get it by itself. Does that work? And I'm going to put step 2 here, which I guess you could call step 2 optional, but for me, step 2 is pretty important, and it's to draw the box. I find that the box is useful. I also have found in enough years of this that some kids, they don't need the box. They don't like the box. They're too lazy to draw the box. There could be a myriad reasons why kids don't do it. But for me, I like to draw the box. So for me, step 2 is, we're going to call it box it up. What is step 3?
Replace, put the box where the, like where the. Substitute the box.
Okay, I'm just going to keep going with this because I went with Bryce's words, but you're welcome to use your words. So your notes should always make sense to you, of course, right? They're for you, not for me. So I'm going to say put the box in the other equation. I'm going to use caps lock on the word other to make sure that we don't do anything crazy like put it back in the same equation. That's no bueno, right? You got to go in the other equation. So put the box in the other equation in place of, how do we say this? The variable we got by itself. Right? So let me get caught up to my own steps here. So since we say that X equals all this junk over here, I'm going to take all this junk over here and I'm going to box it up. The box, again, just is a visual sort of cue for us. And where am I going to put that box? Which, yes, in the top equation. Since we used the bottom equation to make the box, we will replace into the top. So since x is the variable we got by itself, the box is going to go back in place of x into the top equation like that. Everybody still good? So let's show that step, and then we'll write some more steps in blue. So that would look like this. Let me switch to green real quick. So this equation, sorry for all the arrows, this equation will say -5 times an awkward void minus 2y equals 14. And remember, the awkward void is a representation of where the x used to be. And what's going to go into that awkward void? So looking at this now and where we are, what would you say should be a logical step 4? Yeah, and I'm going to go with what Bryce said, just because it won't always be distribution. Honestly, you'll see what I mean when we get through this, but it won't always happen this way. So for step 4, I'm just going to say solve the equation. We all still up to speed here? All right, so let me get, my board has gotten to be a bit of a mess here. Let me see if I can move this equation. I think if I'm careful, I can move this one down here. So there he goes. So that, like I say, I mean, this point in the year, that ought to be light work for you guys. That green and red equation is like, whatever, bring it. What do we get? Yeah, I didn't really mean that. I meant like, what's the next step going to say? 15y plus 40 minus 2y equals 14. And then I am going to go ahead and do 2 steps at once this time because it is January 24th, and I think that we can do that, right? So if I put my y's together, I get 13y. If I simultaneously subtract 40 across to the other side, I get -26. We should be able to do 2 things at once. And then if we divide both sides by 13, we get y equals -2. So I think now is a good time for us to write step 5. And what do we do with that answer, -2? Put it back in the box. Very good. So step 5 is going to be put your answer back into the box. You can see these steps are going to be ineffective for someone who doesn't draw the box, right? They'll be like, what is this box? And that's on you. If you choose not to do that step, then that's yours. But I like the box. And the box, again, gives me, I use it twice. I use it once when I substitute it in right away, and then I use it again. It's like a beacon of shining light that I use 30 seconds later when I then need a place to put my answer back into. Say again? The coordinate area? Yeah, I think what you're thinking of is you're actually, so there was a little step that I did that I don't know if you want to count that as a step or not, Kyla, you're certainly welcome to. But what you're thinking of, I'm pretty sure, is where we started to write our answer. So I'm not opposed to that if you want to make that step 5. Is this what you're talking about where I did my yellow? Sure. So what do we know so far? What does y equal? So I can say this if you'd like, if you wanted to make that step 5. Is that good? And now let's officially hit what we called step 5. If we put -2 up into the box, I don't feel at this point like this is work that I or you should have to show because we're in high school here. So if you put -2, look where my yellow arrow is pointing, right there. Do the math. What's -3 times -2? And what is 6 minus 8? Therefore, the answer is -2, -2. Right? Hopefully that's a satisfactory amount of steps for you. If you wanted to obviously amend them, change the order of something, as I've said before, your notes are totally for your benefit. So, we didn't solve for X, we solved for Y. Yeah, so Y is -2. And so once we know that Y is -2, we have to be sure, look at that yellow arrow, that we're replacing a Y with a -2. And in this case, it worked for you, but only because the answer wound up being the same number. 99.9% of the time that wouldn't have worked. So put it back in the box. That's going to be the key. The box, 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 box. All about that box. Let's go again. We'll go a little bit quicker this time, okay? I'm not going to sit here and write all the steps down. We're going to just do the steps. And I put this in my notes because I wanted to have just a quick conversation with you about this question. Which is the path of least resistance? You could say Y. Bottom Y. What else could you say? You could. And I wanted you to be aware that sometimes it just happens that you have options. So the first one I hear is the first one I'll do. Which one do you want? Bottom Y it is. All right. And so we could easily do this problem by getting X by itself, but I said we would do the first one I heard, you said Y. So we're going to take the bottom equation and we're going to say Y equals, and we're not going to ever mess up stuff like this. It's January 24th. Never do we mess up moving things across equal signs. What does Y equal? Yeah, Kyla, what's up? What an excellent question. The question for the recording, in case you guys didn't hear that, is will there ever be an instance in which there is an X or a Y that's hard to get by itself? And my answer is not while I'm teaching you substitution. Excellent question. I didn't know if anyone would ask that. When I give this assignment, I always make sure that there is at least one path of least resistance. If we encounter a situation where there isn't an X or Y, then that's usually an indication that we should be using the method that we're going to learn in a couple of days called elimination. Great question. So all of today's problems, there will be a path provided for you. You just have to choose. Okay. So I'm going to box this up. And where am I going to put my box? Yeah, sorry. I mean, then where am I going to place the box back into? My question came out wrong. Where's that going to go? In the top equation next to the 4. So remember, if it's Y that we got by itself, then it's Y that we shall replace. And so a little box there to indicate where we're going with this. So my new top equation will say -5x plus 4 awkward void equals 3. And what will go into the awkward void? Good. And then from here, it's just, let's hope our basics are intact. So we distribute, we get -5x, and then what? -4x, and then what? Let me pause this real quick. So let's again do 2 steps at once. Put your x's together. How many do you get? And let's add that 24 to the other side. What do we get? Let's divide everything by -9 and we get x equals. Nice. So going back to Kyla's question from last time, if you liked the way I did that with the yellow, now is when you might want to say, okay, I'm going to start my answer. I'm going to write my answer and say, boom, there it is. That's my final answer in yellow. It's obviously not quite filled in yet, but like you get the idea. So you're welcome. So where are we going to put our -3? In the first spot for sure. And then how are we going to find Y? It would be +3. So what's happening is, again, follow that yellow arrow there. I'm replacing that x that you see there. I'm kind of moving my pen around it. I'm replacing that x with a -3. And if there's already a negative in front of what's about to become a negative, that's definitely a +3 minus 6, which is? So again, we happen to get another answer where the x and the y are the same. Okay.
They all move like that? Or
No. I was picking these out this morning, and honestly, I paid no mind to what the answers were. I was paying attention to the formatting of the equations, but not the answers. So let's do another one and see if it happens 3 times in a row. I honestly have no idea. I didn't write the answers down, so I'm doing these for the first time with you. So, yay. Let's see. Let's do. Oh, I like this one. This one's tricky. No, not super tricky. Choose wisely, young grasshoppers. Which one is better? Bottom Y for sure. Why do we not like the top Y? It's got negative. We're gonna have to deal with that. So why choose that path when the bottom Y is just that little bit easier? So we're hopefully in agreement. We're gonna take the bottom equation and we're gonna get Y by itself. Y equals what? Nice. I'm gonna box that up with my traditional red box movie rental kiosk. And where am I going to put that? In place of the top Y. Very good, because the bottom equation has already been used. So now I'm going to go to the top equation, and where it says Y, whoop, I'm going to replace. So you have to watch out for something like this. So here it goes. So I'm going to write -4x minus awkward void equals -15.
Put a 1 after.
If you'd like to, sure. Yeah, some people do that. I don't, but I will for you, sure. And then what am I going to put into the awkward void? The box stuff. And again, math, the train rolls on. If you're still mooking around with basic skills issues, that's on you, right? We need to know how to distribute 100% of the time. So I'm going to copy down my -4x, and then what do I get when I distribute? Plus 2x and -7. Well played. And then to save a little time, we'll do 2 steps at once here. We'll combine our x's. How many x's do we get? Let's add the 7. What do we get? Good. I love those basics, man. This job is so much more fun when we got our adding and subtracting. So much better. Thank you, guys. And then I divide both sides by -2, and I get x equals. Yeah. So it's time for us to say, okay, if x equals 4, I proudly present to you my final answer. I say final knowing that it's not really quite done, but it's nice to say, there he is. And where will I put that 4? In the x in the box, right there. Follow the arrow. And then you just got to do the little kitty math. And so what is -2 times 4? What's -8 plus 7? So as you can see, we did not get the same thing. So is that enough examples for you guys? I do have one more in the queue, but I feel like we probably are okay. We good? All right. I'm going to stop the recording and I'll hand you the assignment today is on a worksheet. I did not do Delta Math because Delta Math's version of substitution is pretty lacking. It's something they can do a lot better job with. So I went ahead and made it on paper for you guys. So this will be assignment number 6. And I'm not going to say it's due tomorrow. I think we'll probably work on it for the next 20 minutes and then we'll work on it some more tomorrow. That's where I'm at right now. So.